Okay, so we're going to go ahead and update this notebook real quick. We just did this Chapter 7 review. That was the last thing I have in here. Is that good with you guys? Alright, so I'm not sure what page I left off on. I think we're already loading the spot for that. 140. Yeah, we're getting there. We're going to do that right now. I just forgot to number these. Okay, so I use 139 to 145. Okay, what else can we put in here that we could maybe load in here? I think just the test, right? I think that's it. Because we loaded a spot for that quiz. I already handed that back to you, right? So let's go ahead and do 146, the dreaded Chapter 7 test that you all survived, right? Believe me, it really is the hardest test in geometry, I promise you. It's all downhill from here. In the easy sense, that is, okay?
Okay.
It's not too bad. My bad. Okay. So then 147, I think I want to put all of our cast members on, or maybe we should do 4 different pages. What do you think?
Yeah.
Each one gets its own page? All right, so this one, leave a space. We're going to put parallelogram here, because you guys are going to create a name for it. Okay, you may not like DJ Peter parallelogram. You may not like that, but maybe try to think of something that begins with P, something that you guys will personally remember. Because the idea here is to make a, like whenever I say parallelogram, your image should be this thing. And hopefully you're thinking of these properties then. Because you're seeing it kind of mentally in your head, making an association. It's up to you, however you want to name them. Okay? So, then let's go ahead and load up the other ones too. You know what? No, we're going to go right into do some examples, 148. This is going to be parallelogram examples. And once you are all set, you have this updated, go ahead and turn to that page. Is anyone still writing? All right, 148. Right. So, parallelogram examples. And kind of have these properties off to the side, that way you can kind of start getting used to using them. Parallelogram examples. Okay, so 1. So yes, try to draw these figures with me the best you can. They're not too bad though. Of course we have to include algebra. I can't just give you a number. Right, we've got to make it just a slight bit challenging. Okay, so the goal here is find x, find y. So essentially I've given you the problem, I want to throw it back on you. So anyone have a place to start? Brandon. Now, okay, so would you set them equal to each other? Now remind you, this right here is a parallelogram. Okay, let me go ahead and just state that instead of writing it all the time. This is a parallelogram. So are these two angles always equal? No. Okay, not all the time. Okay, so what you think?
Because Brandon was saying set them equal to each other because one of the angles is 90.
Okay.
Can't send them equal to each other.
Good. Okay, so he's using the, how did I write that? That was it in the property number 5. If there's is one right angle, what does that mean about the others? So couldn't I take 3x and set this equal to 90? Because that's what it equals. Couldn't I take 4y and set it equal to 90? I think that's the best approach here, so let's go ahead and do that. So 3x is equal to 90, and 4y is equal to 90. First one over here, divide by 3. X is equal to 30 degrees. Or actually, no, sorry, just 30. And then divide by 4. And what's 90 divided by 4? Say it a little louder. 22 and a half, yes. We're done. No, I mean, these are not too bad as long as you know the properties, okay? And like I said, try to think of it in terms of a rectangle, which I think you all are comfortable with already. You seem to know a lot about it already. You actually know a lot about parallelogram. So, I mean, that's pretty good. Okay, let's do another one. Oh, it would be 2, yes. Thank you. Y, 12, 6x. Again, something kind of basic, but I don't want to go overkill with you. I mean, I could give you a quadratic pretty easily in this. We'll just start pretty simple. Okay. So 4 tick marks, we got 4 congruent sides. What could you tell me, where could you start for this one for getting x and y? Go ahead, Riley.
Since all the sides are set y and it's equal to 12.
Perfect. Okay, same kind of concept except we're not using angles, right? We're using the side measures. Okay, so we know that since one side is 12, okay, then that means that they're all 12. Now, this is a particular case because we have 4 tick marks, right? But if we didn't have 4 tick marks, what other one would have to equal 612? The opposite side, 6x, right? This is just a special case with this example. So 6x is equal to 12. 3y is equal to 12. Oh, I'm sorry. No, that's problem 2. Sorry. Divide by 6 here and we get 2. Divide by 3 and you get 4. Yes?
Did you know that 6 times 2 is 12? You just did it that way.
Sure. Absolutely, yeah. I want you to get comfortable though setting up equations and such. Okay? You're going to see that a lot in here. Alright, another one. Let's give you the more classic looking shape. Give it a diagonal, like that. Now look, you think you got away from triangles, but look, with that one line, what do you got now? Triangles are back to haunt you. You'll see them often. Yes, we're going there. I'm so happy you guys are excited about that, you know.
I love it.
It's not too bad, it really isn't. Alright, so let's think about this. This obviously, we're dealing with the angles here, of course. We've got lots of information about the angles. Where could we go with this? What could we do? Go back and look at your properties and see if maybe we can use about the angles. Yes?
With the 55, we go diagonal to it, but also the 59
You're saying down here?
Yeah.
Will be 55? Very good. Okay, because, okay, this is a parallelogram. These are parallel, correct? They're just not drawn here. But the directions in here say to assume that we have a parallelogram. So since this is parallel, I can drop this down to 55. I can also drop this one down to be 60, right? Now, if you're following the properties of a parallelogram, doesn't it say something about the opposite sides? What does it say? I'm sorry, opposite angles? What does it say? So if this is a total of how many degrees? 60 plus 55 is a total of how many degrees? 115, right? So if this is 115, then this whole thing has got to equal 115, okay? Alright, so we got that, that's a starting point. Now how can I get maybe X now? Go ahead, Justin. Perfect, okay, good. So, do you agree, using consecutive interior, that 5x and this whole thing should equal what? Right, so let's set that up. 5x plus, we already said that's 115, equals 180. Okay, so subtract 115. So I get 5x is equal to, what's 180 minus 115? 65. Divide by 5. And x equals 13. Excellent. Okay. Alright. Now how do I go after y? What strategy you got for y? Same thing. Okay, so you're going to say that 2y plus 115 equals 180. That's good. 115 equals 180. Okay, subtract 115 from each side. 2y is equal to another 65, right? Divide by 2, and what does y equal? 32.5. Okay. Questions on that? Would anyone have gotten this one a little differently? Anybody have another idea? Let's just kind of think about maybe if we could have used the properties a little bit different. Avery, did you have your hand up?
Couldn't you have just like, well, never mind, it's kind of the same thing. Like if you just added, if you did it like the triangle equals 180 instead of
Perfect. Okay, good. So she's using the triangle here. You know that okay, so you've got 60 degrees, 55 degrees, and then you've got some leftovers, right? This should be equal to the leftovers, right? Okay, perfect. Those leftovers, believe it or not, isn't that also right here? Since you have what x is 13, 5 times 13 will give you this degree measure. Opposite angles are congruent. You could have just set them equal. Good. Okay. All right, so let me give you guys one to try. See what you can make of this. Shouldn't be too bad. 2y, 72x. 150 and 30x. Can you guys see that's supposed to be an x? Sorry. And find x and y. Assume it's a parallelogram. Questions? Guys, look like you guys are on the right track. Looks good. And just for the sake of time, because the lunch bell's going to get us in a few minutes, how can I go after, let's start with x. I think that has to be kind of your starting point here. Caitlin. Why? They're parallel, and what else? What's true about opposite sides? That's right. These two sides, they better be equal if it's a parallelogram, right? So 30x is equal to 150. You weren't expecting that question, were you? You had this look of like, huh? But good job. Divide by 30, and x equals what? 5. 1 down. Now we just got to find y. So for those who did find y, what was your strategy? By the way.
I multiplied 72 by 5.
Okay, so you plugged it in. So when you plug 72 times 5 in, what'd you get?
I got 360.
72 times 5? 360. Okay.
And then, because it's a rectangle, the top side has to be equal.
Okay.
So I just did 2x equals 360
You meant 2y, but yes. Yep, equals 360. And divide by 2. Okay, good. So y is equal to, now you said rectangle, but just counting in this for this lesson, parallelogram. I know that's what you meant though. Okay? Any questions on this? When we come back from lunch, we're going to tackle the diagonals and do some questions that involve the diagonals. But for right now, since the bell's entering, this is a good stopping point.